Hey everyone, GraphDBA here with another video, and today we are going to create some ASM disks and disk groups for Oracle RAC 19C on Linux using a PowerMax 8500 storage array and PowerPath. But first, some boring legal stuff. Now, I'm not going to read through the whole slide, just be aware that I work for Dell Technologies, and that said, all opinions are my own and do not necessarily represent Dell or any of the subsidiaries. Everybody good? Okay, cool, let's move on. There's a really excellent white paper titled Deployment Best Practices for Oracle on PowerMax, written by my good friend and colleague Yaron Dar. If you need to create ASM storage on a PowerMax, I strongly recommend that you review that document. I've copied a few of the key points here. Use ASM external redundancy for all of your ASM disk groups, except grid where we recommend normal redundancy. At a minimum, separate data, redo, and FRA into their own ASM disk groups. You might well need more depending on your databases, and to be fair, if it's a small development database, even 3 might be overkill, but it's a good starting point. Keep your ASM disk groups in separate PowerMax storage groups. For extra performance, use ASM fine-grained striping for the redo logs. Again, for performance, we recommend a minimum of 5 redo log groups, typically with 2 members per group, and make the redo logs large enough to avoid excessive redo log switching. We've suggested 8 GB as a starting point here. You might need larger or smaller depending on your needs. ASM filter drivers are excellent and we strongly recommend them. Combined with PowerMax thin provisioning, they allow for storage reclamation. Okay, so here we are in Unisphere, the graphical interface that we use to manage the PowerMax. We could also use the command line option, which is called Solutions Enabler, and I will have a blog post on how to do that in due course. But Solutions Enabler is not typically installed on a database host, so most DBAs would use Unisphere anyway. Now, we could just go ahead and start creating volumes for our ASM disks, but we like to use storage groups, and since we plan on segregating data and redo, we like to have a storage group each for both of those ASM disk groups, and then both of them to be part of a parent storage group. So we'll start by creating an empty storage group, and we'll call it Swing SG, as this is a storage group for Swing Bench. Next, we'll select our new empty storage group and select SG Maintenance, and then convert to Cascaded. This will prompt us to choose a name for a new child storage group, so we'll name the first one Swing Data. Next, we need to add some volumes to our new storage group, so we'll click on Storage, Volumes, and then the Create button. ASM disk groups usually need more than one disk, so we'll create 4 new volumes at 1 TB each, and we'll add them to the Swing Data storage group. Now, if we select Advanced Options, we can choose to name our new volumes, and in this case, I am going to name them and append a volume number. I'll set the name to Swing Data, click OK, and then click Run Now to create the volumes. In this example, Unisphere tells us that the PowerMax has created 4 new volumes, 1 Baker 0 through 1 Baker 3. If we don't name our volumes, the PowerMax will just assign the new volumes as an ID. Experienced administrators might be comfortable with this, but as a casual Unisphere jockey, I find that approach can be confusing, especially when you're trying to find your volumes in a large PowerMax. It's up to you, of course, so name or don't as you see fit. If we scroll through the list of volumes on this PowerMax, we can find our new volumes at the end of the list, and you can see why naming the volumes is much simpler for the casual Unisphere user. Next, we'll create the Swing Redo storage group, so select Storage Group and then Create. We'll name our new storage group, and we'll disable data reduction on this group as it will be used for redo logs, which don't compress especially well, are not that large, and are highly performance sensitive. Now, we could create the volumes we need in this screen, but if we do that, we cannot name them. So instead, we'll go back to Volumes and create 4 new volumes at 64 GB each, and add them to the Swing Redo storage group. And we'll name them, and since the Swing Redo storage group does not have data reduction, we can specify these volumes to be thickly provisioned and not subject to storage reclamation. For most applications this is overkill, but for performance-intensive databases, it adds just a little bit of extra performance. The PowerMax creates our 4 new volumes with IDs 1 Baker 4 through 1 Baker 7. Next, we want to make Swing Redo a child of Swing SG. So we're going to go back to Storage Groups and select the Swing SG storage group. Then we're going to click Child Storage Groups and select the Add option, and scroll down through the list and select the Swing Redo storage group that we just created. Now if we go back to our storage groups, you will see that both Swing Data and Swing Redo are both children of Swing SG. Next, we need to provision our new storage to our Oracle RAC database hosts. So we'll highlight the parent storage group and we'll select Provision. And then we'll select the host group RAC Metro, which is a host group of our Oracle RAC database servers. For the port group, our storage admins have already created a port group that utilizes ports on both of the directors and takes care of all the zoning and pathing. So we'll select the existing port group 304FC. When I click Next here, Unisphere tells me that it is going to create a new masking view called Swing SGMV. When we click Run Now, the storage is provisioned and should now be visible from the host database servers. If we click on Hosts in Unisphere and select Masking View, we can see the newly created view. Now that we have provisioned the storage, we can move to our database servers and rescan the SCSI bus to see if the new volumes have appeared. We are going to use the s3gutil script rescan scsi-bus.sh to, well, rescan the SCSI bus. I'll provide a link to it in the description and into the blog post that goes along with this video. We'll need to do this on all the hosts in our RAC cluster. The script will run for a minute or so depending on the number of devices and paths involved. When the script completes, we will use the command powermt check dev equals all. This tells PowerPath to check all devices, adding any new devices found and removing dead ones if you took any devices away. Now we want to check if our new devices have shown up. There's a few different ways we can do this. SIMINQ is a command line tool that will show all the devices sourced from the PowerMax. It shows the local device name, the device serial number, and the capacity in gigabytes. If we scroll up, we can see our 4 1TB devices for Swing Data, our 4 64GB devices for Swing Redo, and the 4 2TB devices you see are PowerMax volumes I created for the Swing Bench flash recovery area. SIMINQ shows pseudo devices presented by PowerPath as well as the raw SCSI Linux devices where the same block device will appear multiple times due to multipathing. We are only interested in the PowerPath devices and we can ignore the raw SCSI devices. PowerPath has already taken care of that for us. Matching new devices by volume size is fine in many cases, but if we're adding to an existing ASM disk group or we have existing devices of the same size, then we might need to be a bit more thorough. SIMINQ allows us to see the worldwide name of the devices if we specify -dubdubn on the command line, but then it doesn't show the capacity. I use this quick and dirty shell script to report both capacity and the worldwide name. Alright, so here are our 4 2TB volumes. If we go back to Unisphere for a moment, let's find our volumes. And here is volume Swing FRA3, and we can see that the last 8 numbers of the worldwide name are 30, 31, 42, 42. And if we check out SIMINQ output, we can see that device/dev/emc power J is that same volume. If we have Solutions Enabler installed, we can use the command simdevlist and specify the storage group we want to see, in this case Swing SG. Here we can now see the 4 1TB volumes and the 4 64GB volumes. SimDev also reports the device IDs. If you want to see the worldwide names, SimDev also lets you see that with the dubdubn switch. You can see that we have a total of 12 new devices, 4 of each capacity, and PowerPath has presented them as /dev-emc power A through /dev-emc power L. What we need to do next is to repeat the SCSI bus rescan step and the PowerPath check step on each node of our RAC cluster so that all nodes can see the new volumes that we've created. I've now moved to the second node of my RAC cluster. I'm going to rescan the SCSI bus and tell PowerPath to check for new and remove volumes. There's no guarantee that PowerPath will assign the same device names on the other nodes of the RAC cluster. What is /dev/emc power A on node 1 might be something quite different on node 2. With ASM filter drivers, or ASM lib, we don't really care, as Oracle ASM relies on the ASM disk label on the disk itself and not the device name chosen by PowerPath. But if you want to ensure that volumes have the same device names on each node of the rack cluster, you can use the PowerPath command emcpadm export mappings to export the device mappings from the first node, and then emcpadm import mappings to import those same mappings on each subsequent node. Import mappings can only assign the requested device name if it is not already in use. So if you want to maintain device name consistency across the cluster with this approach, make it your standard and stick with it. With all new volumes presented to all nodes of the cluster, we can use ASM to label the disks. I'm back on node 1 and I have my list of new volumes. I will use the command ASM CMD AFD label to label each of the 4 volumes for the new swing FRA disk group. Once we've labeled all of the disks, we can swap to node 2 and then use the command ASM CMD AFD scan to scan for the new disks, and then ASM CMD AFD LSDSK to show the DBA what ASM has discovered. We need to repeat this ASM disk label operation for all the new volumes for our data and redo disk groups. And once that is done, the ASM instance on all nodes of the rack cluster should be able to see all of the new volumes. Finally, we can launch the ASM configuration assistant to create the new disk groups. You'll note that our disk discovery string is set to /dev/emc power star and afd:*. ASMCA has found our new candidate volumes. We'll create our new ASM disk groups using external redundancy and an AU size of 4 megabytes. There's some additional best practices contained in the white paper reference at the start of the video, and I go into some more detail in the accompanying blog post. Alright, that's all we have time for today. Hope you found it helpful. If you did, maybe click like. If you found it really helpful, maybe even subscribe to the channel. And you're always welcome to come check out my frequently gruff but hopefully always helpful Oracle insights at my blog, gruffdba.wordpress.com. Stop by sometime. We'd love to see you.